Cold open. Every time a chat message appears without you refreshing the page, or a stock ticker updates itself, or you see someone else's cursor moving in a shared doc, a WebSocket is doing that. You've probably used the word 100 times. Oh, that's real time. It's using WebSockets. And the mental model most people carry around is, WebSocket is just a faster kind of HTTP. A persistent version of the same request-response thing your browser already does. That mental model is wrong, and it's wrong in a specific, useful way. A WebSocket doesn't start as something else. It starts as a completely normal HTTP request, the same kind your browser sends for every page load. And then, at one exact moment, it stops being HTTP entirely. Not faster HTTP, not HTTP but persistent. Something else. A raw, bidirectional pipe that happens to be born inside an HTTP handshake. Today, we're watching that transition happen. The exact millisecond a connection stops being one protocol and becomes another. The problem plain HTTP can't solve. Start with what HTTP actually is. A request-response protocol. Client asks a question, server answers, connection's done, or kept idle for reuse, but the shape never changes. Client speaks first, always. The server is not allowed to just say something to you. It can only reply to something you asked. So what happens when the server has news you didn't ask for? A new chat message arrived. The stock price moved. Someone else typed a character in the doc you're both editing. HTTP has no built-in way to say, hey client, here's something. Because in HTTP's world, the server only ever speaks when spoken to. For years, the workaround was polling. The browser just asks over and over, anything new? Anything new? Anything new? Every few seconds, a full new HTTP request, full headers, full round trip, most of the time for the answer no. Long polling made it slightly less wasteful by having the server hold the request open until there was actually something to say. But it's still HTTP's shape, bent as far as it'll bend. Client still has to ask first, every single time. What you actually want is a connection where either side can just talk, whenever it wants. That's not a feature you can bolt on to request response. It's a different kind of connection altogether, which is exactly what a WebSocket is. The handshake, an HTTP request in disguise. Here's the part that surprises people. A WebSocket connection doesn't begin with some special new protocol. It begins with a completely ordinary GET request. Same TCP connection, same HTTP headers you'd see anywhere, with a few extra headers that mean something specific. The browser sends upgrade, WebSocket, and connection upgrade, literally asking the server, can we change what this connection is for? It also sends a sec WhatsApp key, a random base64 encoded value generated fresh for this one handshake. If the server is willing and able to speak WebSocket, it doesn't reply with the 200 OK you're used to. It replies with status code 101, switching protocols. A status code that exists for exactly one reason, to say, you and I are about to start speaking a different language on this same wire. Along with it, a sec WebSocket accept header. The server takes your key, appends a fixed constant defined in the spec, hashes it, and encodes the result. Proof that it actually understood the request, and isn't just some random HTTP server ignoring the upgrade header. Both sides now agree, and that agreement is the entire point of the handshake. It's the last HTTP-shaped thing that will ever happen on this connection. The exact moment it stops being HTTP. Right after that 101 response, something most people never think about happens. The TCP connection doesn't close and reopen. It's the exact same socket, the exact same already open pipe between browser and server. But from this point forward, nobody sends HTTP requests or HTTP responses down it again. Ever. For the rest of this connection's life. There's no more client asks, server answers. There's no more headers per message, no more status codes, no more URLs. What flows down the wire now is WebSocket frames, a much smaller, simpler unit, and either side can send one whenever it wants, in whatever order it wants. The server can push you a message with nobody having asked for it. That's the entire capability HTTP couldn't give you. Unlock the instant the handshake completes.
This is why calling it an HTTP connection that stays open undersells what happened. It's not HTTP with the connection left open.
It's a completely different protocol, now occupying the same physical connection that HTTP briefly used to negotiate it into existence. What a frame actually looks like. A WebSocket frame is deliberately tiny compared to an HTTP message. No headers, no status line, just a small binary header describing what's inside, followed by the payload itself. That header carries an opcode, a few bits saying what kind of frame this is: text, binary, a ping, a pong, or a close signal. Pings and pongs matter more than they sound. Either side can send a ping just to check, "Are you still there?" And the other side is expected to answer with a pong. That's how a WebSocket detects a dead connection without waiting for a message that may never come. One quirk worth knowing: any frame sent from the client to the server has to be masked. The payload gets XOR'd with a small random key before it goes out. Frames from server to client don't need this. It's not encryption. It exists to stop certain proxies from being tricked by raw bytes that happen to look like other protocols. Small detail, but it's in the spec for a real reason. Why this actually matters? Put it together: one handshake, one persistent connection, frames instead of full messages, either side free to speak first. That's what makes a live chat feel instant instead of laggy. It's what lets a multiplayer game push position updates without begging for them. It's the same idea underneath collaborative editors showing you someone else's cursor moving in real time. The server has something to say, and for once, it doesn't have to wait to be asked. But it's not free. That open connection has to be held somewhere, which means your server is now stateful in a way plain HTTP never forced it to be. Scale that to 10,000 connections, and you can't just round-robin requests across servers anymore. You need whoever holds that socket to keep holding it, or a pub/sublayer behind the scenes so any server can push a message to any client. There's no CDN caching a WebSocket response, because there isn't a response to cache. And some corporate proxies still choke on the upgrade header and block the handshake before it even starts. None of that makes WebSockets the wrong tool. It makes them a different tool, one you reach for specifically because you need the thing HTTP structurally cannot give you: a server that gets to talk first. So next time you open a chat app and a message just appears, you're not looking at fast HTTP. You're looking at a connection that used HTTP for exactly one handshake, then quietly became something else entirely. If this finally made WebSockets click, drop a like and subscribe, and tell me in the comments which protocol I should take apart.